Let us continue ionic equilibrium. In ionic equilibrium, we are seeing about indicators. In the indicators, we are taking which one in the sense? Phenolphthalein indicator we are taking. That phenolphthalein indicator structure we will write. We will draw the structure of phenolphthalein. Here one phenyl ring. Here C double bond O. Here O. Here carbon. Here one phenyl ring. Here OH group. This carbon is having another phenyl ring and OH group. Now this compound is donating H plus because it is acid. It is organic compound, therefore we can say organic acid. Since it is having less acidic nature, we can say it is weak organic acid. It is donating H plus and becomes so and so. Here C double bond O, this O becomes O minus. Here C, this is having one phenyl ring. Here OH group will be there. Here double bond. Here pi bonds like this. Here double bond like this will be there. Now we will take a aqueous solution of phenolphthalein. Now we are taking aqueous solution of phenolphthalein. We will take aqueous solution of phenolphthalein. We are taking. In the aqueous solution of phenolphthalein, such a type of equilibrium will be there. In the aqueous solution of phenolphthalein, this species will be present, H plus will be present, and this species will be present. So in this solution, in the aqueous solution of phenolphthalein, these three components present in the aqueous solution of phenolphthalein cell. Now we can say that this species can donate H plus. Therefore, this species is called acidic species, we can say. This species can take H plus and become so and so as per backward. Therefore, this species we can say basic species we can say. Okay. Next, this species on ionization gives so and so. Therefore, it is going for ionization. So before ionization, it is not ionized species. It is not ionized species. Okay, it is not ionized species. This species on ionization gives this one. Therefore, this one we can call it as a ionized species. We can call this is as a ionized species. We can call. Then in this species, this is called phenyl ring, benzene. Phenyl rings present, benzene rings present. Therefore, this is called benzenoid form. We have to call this is as a benzenoid form. We have to call. Then in this species, so and so structure is present. So and so structure is present. This is called quinone. This is called what in the sense? Quinone. Now, this quinone structure is present in this species. Therefore, it is called quinonoid form. It is called quinonoid form, we can say. Sir. Next, this benzenoid form always possess less intense color. This benzenoid form always possess less intense color. This quinonoid form always possess more intense color. More intense color. So this benzenoid form is having less intense color. Quinonoid form is having more intense color, we can say. This species is colorless. This form is colorless, whereas this form is pink color. This ionized form will exhibit pink color. This ionized form will show pink color. This unionized form will show colorless. Now, like this, Ostwald theory and the quinonoid theory explains about this phenolphthalein. Now, this is a colorless we are saying. It is a pink color we are saying. Now, what about this aqueous solution of phenolphthalein? This aqueous solution of phenolphthalein is almost colorless. That means this equilibrium lies almost this left side. Therefore, we can say this is weak acid. We can say this acid is weak acid. We can say, okay, sir. This about phenolphthalein. We can say. Now, let us take a aqueous solution of HCl. Now we are taking aqueous solution of HCl. This HCl, aqueous solution of HCl, how to prepare in the sense, we will prepare HCl gas. That HCl gas we will pass into water, we will get aqueous solution of HCl. This solution is what in the sense? Colorless. HCl is a strong acid. Therefore, in this solution, HCl exists in the form of what in the sense? H plus ions and Cl minus ions. This equilibrium lies which side? Almost right side. Why? Because it is strong acid. Okay, now this aqueous solution of HCl will take. To this, let us add phenolphthalein. To this aqueous solution of HCl, we will add phenolphthalein. Phenolphthalein is what? Indicator. Generally, how much indicator we will add for titration in the sense some 1 drop, otherwise 2 drops, maximum 3 drops. Like this only we have to add indicators. Indicators we should not add much extent. Correctly 1 drop you add, 1 drop of indicator or 2 drops of indicator, 3 drops of indicator, like this only we have to add. Drop in the sense how to know this is so and so drop. Using dropper tube, we can take phenolphthalein solution and we can add 1 drop or 2 drops, like this we can add. Okay, therefore we have to add correctly phenolphthalein indicator. So we have added phenolphthalein indicator. This phenolphthalein indicator will go for ionization. This phenolphthalein indicator will be in equilibrium in the resultant solution. That equilibrium is phenolphthalein is in equilibrium with H plus and pH minus. This HPH is called what in the sense this unionized form. This unionized form we are abbreviating as HPH, phenolphthalein. Then this pH minus is called ionized form. This pH minus, this ionized form is pH minus. This ionized form is what? pH minus we can say. Now let us see. This is purely aqueous solution of phenolphthalein. In this aqueous solution of phenolphthalein, so and so equilibrium is there. In this one, we will take the concentration of this. It has some concentration. This has some concentration in this solution. Now we will see in this solution. Now this phenolphthalein is added into what? Aqueous solution of HCl. Now we will take the concentration of this unionized form. Let us compare this unionized form concentration and this unionized form concentration. Let us compare how it will be there. This is unionized form concentration means in aqueous solution of phenolphthalein. Here unionized form of phenolphthalein means in the aqueous solution of HCl. Now how the concentration of phenolphthalein unionized form will be there in these two solutions? How it will be there in the sense that concentration will be high here and the concentration will be low here. Unionized form concentration will be low in the aqueous solution of phenolphthalein, whereas in this solution unionized form of phenolphthalein concentration will be high. Why? Because this aqueous solution of HCl is giving H plus. That means aqueous solution of HCl is giving H plus common ion. Aqueous solution of HCl gives H plus, therefore concentration of this H plus getting raised. So backward is favoring. Backward is favoring in the sense unionized form concentration is rising. Okay, therefore in the phenolphthalein is added into this solution. Now in this equilibrium, which concentration is high means unionized form concentration is high when compared to indicator, separate indicator. So this concentration is dominating when compared to this concentration. This concentration is dominating when compared to this concentration. Therefore, this phenolphthalein will give which color to this solution? Unionized form color to the solution this phenolphthalein gives. So this phenolphthalein gives this unionized form color to this solution. Therefore, this resultant solution will exhibit which color? Resultant solution exhibit color of this unionized form. This unionized form is having what color? In the sense colorless. Therefore the resultant solution is colorless. So on adding aqueous solution of phenolphthalein, on adding aqueous solution of phenolphthalein into aqueous solution of HCl, the resultant solution remain colorless. Why? Because in the phenolphthalein unionized form will be dominating, which has colorless. Therefore resultant solution is having colorless. Okay, next, now we will take a aqueous solution of sodium hydroxide. Aqueous solution of sodium hydroxide will take. How sodium hydroxide will be there? Sodium hydroxide, when preparing time, manufacturing time, how they will prepare? In the sense just it will be like pellets. It will be like pellets. How doll is there? Pellets manner it will be present, and it is white, it is colorless. So this is added into water and we are getting aqueous solution of sodium hydroxide. This solution is what? In the sense colorless solution. To this let us add a drop of aqueous solution of phenolphthalein. This aqueous solution of phenolphthalein is colorless. Okay, this is added into this. Now what happens means this phenolphthalein goes for ionization in this solution. Therefore phenolphthalein goes for equilibrium. That equilibrium is so and so equilibrium will be there in this resultant solution. So in the resultant solution so and so equilibrium is present. So now let us compare the concentration of pH minus in the resultant solution with the aqueous solution of this phenolphthalein. Now we will compare these two concentrations. How these two concentrations will be there, that we will see. Okay, so now we are seeing the concentration of this ionized form in the aqueous solution of phenolphthalein and ionized form of phenolphthalein in this resultant solution. How the concentration will be there? Do you know? Here concentration will be high, here concentration will be low. What had happened? Why the concentration is changed? Why concentration of ionized form is high in that case, but in this case low? What had happened? Because aqueous solution of sodium hydroxide gives hydroxide. That hydroxide neutralizes this H plus. Aqueous solution of sodium hydroxide consumes this H plus for acid base neutralization. Therefore concentration of H plus getting reduced. Concentration of H plus right side reduced in the sense forward favors. Forward is favoring. Forward is favoring in the sense this concentration is getting raised. Therefore in the aqueous solution of sodium hydroxide we are adding phenolphthalein. In the resultant solution this concentration is dominating. Ionized form concentration is dominating. Therefore this resultant solution is having which color? In the sense this ionized form color. This ionized form is dominating in the resultant solution. So it is having which color? That color will be appearing in the resultant solution. So this is having what color? Pink. Therefore resultant solution is having what color? Pink. Okay, so that now resultant solution is having pink color, we can say. Okay, this we said superficially. Actually what color? What is the intensity means? Based on concentration we have to see. Okay, so that we will see later. So superficially we are saying now the resultant solution is having this concentration higher. Therefore resultant solution is having the color of this ionized form, that is pink color. Like this we are saying. Okay, this is about phenolphthalein indicator. Now we will take another acid base indicator, that is methyl orange we will take. Now we are taking another acid base indicator. What is that? In the sense methyl orange. Methyl orange indicator we have taken. Sir, what is the formula of this methyl orange indicator? That we will see. In this methyl orange indicator one phenyl ring present. Okay, then another phenyl ring is present. In this methyl orange indicator two phenyl rings present. Between these two phenyl rings what group is there? Means azo group is present. Between these two phenyl rings what group is Present means azo group is present. Azo in the sense N double bond N you have to give. So here it is called what in the sense azobenzene we can say. Next, in this phenyl ring at para position means what? For this nitrogen opposite carbon. This is para position. At para position, amine is present. That which amine? Tertiary amine. Therefore, here one alkyl group methyl we are writing. Here one alkyl group methyl we are writing. It is called tertiary amine is present. Then this azo group, this para position, this side para position, what is there means SO3 minus is present. Okay, so like this is present. This is called what in the sense methyl orange. Now this SO3 minus, how to write SO3 minus in a structural formula we'll see. Now one oxygen, second oxygen, third oxygen, negative charge you give it. SO3 minus we said no, so negative charge is there, no, that negative charge give to oxygen. So we gave so and so for methyl orange. Now what this methyl orange does in the sense it takes H plus. Okay, it is taking H plus. Okay, this methyl orange is taking H plus. Which part is taking H plus? That you will see. Okay, so which and all can take H plus? Which and all can take H plus? What is a possibility? One possibility, this O minus can take H plus. If O minus takes H plus, then we will get what in the sense here two methyl groups, N, here one phenyl ring, then N double bond N, here one phenyl ring, then S double bond O, O minus becomes OH. One possibility like this. Okay. Is there any other possibilities? We will try. Okay. Now this nitrogen is having lone pair. This nitrogen is contributing lone pair to this H plus and making dative bond with this H plus. So this is one possibility. Okay. So that possibility will take. So two methyl groups and N, here lone pair, here phenyl ring is there, N double bond N, here phenyl ring is there, then this SO3 minus. Now this is making dative bond with this H plus. This is one possibility we said. Okay, next. Is there any other possibilities in the sense this nitrogen can take H plus, then this nitrogen can take H plus? These are the possibilities. Okay, so what are the other possibilities that we are seeing? Okay, and now other two nitrogens can take H plus. So this nitrogen is able to take H plus, then we can write like this. Then this nitrogen can take H plus. And think that it is monobasic, it is monoacidic, therefore it can take one H plus only. Okay, so like this, these are the possibilities. Now this is monoacidic in the sense this methyl orange can take only one H plus. Only one H plus means which species will take that H plus? Out of this, which species is taking H plus? That we have to see. Now this SO3 minus, if you see, it can go for resonance. How it can go for resonance? In the sense this lone pair and this pi bond are in conjugation. Therefore, these two are in conjugation in the sense these two can go for resonance. Similarly, these two can go for resonance. Because of resonance, it is having stability. It is having stability in the sense it is having less tendency to take H plus. So, another possibility we'll see. Now, so this is having less stability to take, it is having more stability, therefore it is having less tendency to take H plus we said. Next, regarding this nitrogen is taking H plus means this nitrogen is contributing lone pair. This nitrogen is contributing lone pair in the sense this nitrogen will get positive charge. How it is getting positive charge you will see. Now this dative bond we will write it as normal covalent bond, then we will give formal charges. Formal charges in the sense for donor we are giving +1, for acceptor we are giving -1. For this -1 if we give, this will become net charge becomes 0 because already it is having +1. Okay, therefore here we will write 0 we will write. Sir. for this charge is 0. Now it got positive charge. This positive charge, will it be stabilized? Will it be stabilized or not? That we'll see. Whether this positive charge is stabilized or not stabilized, that point we'll see. Okay. Now what is happening in the sense, this pi bond is shifting to this end. Okay. Pi bond is shifting in the sense, here resonance is possible, we are saying. Okay. Pi bond is shifting in the sense, here resonance is possible. Correct? Sir. Here resonance possible, we are saying. Next, it is getting deficiency, therefore this pi bond is shifting here. This carbon is getting deficiency, therefore this pi bond is shifting here. This carbon is getting deficiency, therefore this lone pair is shifting here. So see that it is a contributing lone pair, therefore this nitrogen is getting deficiency. Since it has got deficiency, how many species are helping to this nitrogen, you see? So because of these many help, this nitrogen is contributing lone pair to this H plus and goes for resonance. That resonance structure we will write. This resonance structure we will write here. That is Me, 2 times Me. Then this N. Now this N is contributing lone pair, and therefore this pi bond, this single bond becomes a double bond. This N is contributing lone pair, therefore loss of 1 electron, therefore positive charge for this N. Then that phenyl ring we will write. Here this pi bond goes to this place. This pi bond no change. This pi bond becomes here, therefore this single bond becomes a double bond. Then N, this double bond becomes single bond. Now this N is getting lone pair, pi bond is becoming lone pair here. Here already lone pair is there. This H we will write. This N is getting a lone pair, pi bond is becoming lone pair, therefore gain of 1 electron, therefore minus 1 we have to give. Already plus 1 is there, net charge becomes 0 for this nitrogen. Then we will write this phenyl ring. That phenyl ring we have written. Then SO3 minus we will write. Okay. Sorry. So this nitrogen is contributing lone pair. It is accepting H plus in the sense this is supported by these many species. Therefore, it is contributing lone pair and taking H plus and making bond with H plus. Sir, okay. What about this nitrogen? This nitrogen also having lone pair. Can it contribute H plus? Can it contribute lone pair? Sir, if it is contributing lone pair, it will take H plus. That is like this. Like this will be there. Okay. Now this dative bond, we will write it as normal covalent bond. This dative bond we are writing as normal covalent bond. Therefore, we will give formal charges. What is the formal charge we have to give in the sense for this nitrogen? Plus 1 we have to give. Now, this is having plus 1 charge. Therefore, which and all will support this? That we'll see. This pi bond can come here. This pi bond can go here. This lone pair can come here. Okay. Like this support will be there. So, and this side support will be there or not? This side one support is there. If this side support is there means we cannot go for this side support. Any one side we can take. Otherwise, partial only we can take. Therefore, here if you see, for long extent conjugation is there when compared to this. Therefore, this is having higher tendency to contribute lone pair when compared to this. Therefore, we can consider this part instead of this. Okay. Then we will take this. Here if you take, now if this nitrogen is contributing H plus means, which side support will be there? Means you can say that this side support. This side support we can say, isn't it? So this side support is there in the sense this nitrogen can contribute H plus, isn't it? Sorry. Now another factor is there. That factor is what in the sense here it is a tertiary amine, therefore it is having less tendency to take H plus because of steric hindrance we can say. Therefore this part is having more tendency, more contribution. Therefore, in methyl orange, we can say this nitrogen is having higher tendency to take H plus when compared to other species. Therefore, this nitrogen is making bond with H plus, so that we will get so and so resonance structure we will get. Okay, sir. Next we will write this. Therefore, in methyl orange, so and so equilibrium is possible, we can say. Okay, so in methyl orange, so and so equilibrium is possible. Okay, so in methyl orange, what is the possibility we said? Okay, in methyl orange, which is a ionized species, which is unionized species, we'll see. So in the methyl orange, first two letters will take Me, that Me will take, and this O minus I will write. Okay, this we will write it as MEOH, I will write. This I will write it as MEOH. Okay, sir. So because that has accepted H plus, therefore I have written like this. So MEO minus plus H plus gives MEOH. Okay, methyl orange I have written like this. This I have written as MEO minus. This I have written as MEOH. Like this I have written. Sorry. Now this is this species we will take. This species takes H plus, therefore it is base. It is organic compound, therefore it is organic base. And for this equilibrium constant is less, therefore it is weak organic base, we can say. Therefore this species is called a weak organic base, we are saying. Okay, this is a weak organic base. This is weak organic base, we said. Okay, then since it is a base, it is basic form, we can say it is. Therefore it is what? Acidic form. How do we say it is acidic form? It is giving H plus in the backward, therefore it is acidic form, we can say. Okay, next one is this is taking H plus and becomes ion, therefore it is a ionized. This is what in the sense ionized form. This is a unionized form, we can say. It is taking H plus and becoming like this, therefore it is unionized form, whereas this one is a ionized form, we can say. Therefore this one is called a unionized form. Unionized form. This is called a ionized form. Don't think that here minus sign is there, therefore we have to give ionized form like this. Don't give it. Okay, so we are calling this is as unionized form with respect to what? With respect to this H plus, not with respect to this minus. Okay, so it is taking H plus and becomes like this, getting like this positive charge. Therefore we are calling this is as ionized form. This we are calling as unionized form. We are not considering this minus. Okay, sir. Unionized form, ionized form we said. In this one, it is phenyl ring. It is phenyl ring. That means benzene ring is present here. Therefore, it is called a benzenoid form. This we are calling as a benzenoid form. We are calling. Okay, benzenoid form. So benzenoid form we are calling. This one is what we will see. Okay, in this one, quinone ring is there. Therefore, we can call this is as a quinonoid form. This we are calling as a quinonoid form. It is quinonoid form, we said. Next, we have to say that benzenoid form is having less intense color. Quinonoid form is having more intense color, we can say. It is less intense color, therefore it is yellow. This what in the sense yellow. This is what in the sense red. This what in the sense red. This quinonoid form is having red color. This benzenoid form is having what color in the sense yellow color, we can say. Okay, now methyl orange we have taken. Now we will take aqueous solution of methyl orange. In that, how it will be there, how this aqueous solution of methyl orange will be there, we will see. Aqueous solution of methyl orange I have taken. This aqueous solution of methyl orange is having so and so equilibrium. So and so equilibrium will be there in the aqueous solution of methyl orange. Okay. Now this aqueous solution of methyl orange will appear, what means it will appear yellow color. This aqueous solution of methyl orange will be appearing what in the sense yellow color. That means in this equilibrium, which is dominating, aqueous solution of methyl orange means what should be there? Methyl orange and water should be there. Okay, so in the aqueous solution of methyl orange, so and so equilibrium is there. that solution is appearing what color in the sense yellow color. That means out of these two species, which species is dominating? So and so. Now have you understood why we said it is weak acid, weak base? Because this species is dominating means it is having less tendency to take H plus. Therefore only we are saying it is weak. Okay, now shall we say methyl orange is weak organic base? Okay, so methyl orange is weak organic base. It is having yellow color, we said. Now let us take aqueous solution of HCl. We will take. Now I am taking aqueous solution of HCl. To the aqueous solution of HCl, let us add methyl orange indicator 1 drop, otherwise 2 drops, otherwise maximum 3 drops. Don't add more than that indicator in the sense it is needed to indicate the endpoint. That's all. It is needed to indicate the color change. That's all. So don't add indicator much. Okay. So we added a few drops of indicator into this solution. Now the resultant solution color is what? What is the color of resultant solution? That we'll see. So this methyl orange is a weak organic base. Okay. If this methyl orange is a weak organic base, you are adding acid into this. Okay. So what will happen? We'll see. Now you are adding acid in the sense concentration of H plus will be high, isn't it? It is the aqueous solution of methyl orange. In aqueous solution of methyl orange, so and so equilibrium is there. Now we are adding this indicator into which solution? Aqueous solution of hydrochloric acid. HCl is a strong acid that gives H plus ions. Therefore, concentration of H plus will be raised. Concentration of H plus is raised in the sense which is favoring forward or backward. Forward is favoring. Forward is favoring means which species is dominating now? So and so species is dominating. So and so species is dominating means it is exhibiting which color? Red color. Therefore, what is the color of resultant solution? Red color, we can say. Resultant solution color is red. So if you add methyl orange into aqueous solution of HCl, we will get resultant solution is red color, we can say. Okay, this is this we said superficially. Okay, actual is what? Actual is what in the sense that we have to talk with respect to pH of solution. Based on pH of solution only we have to say which color we have to say. Superficially we said here. Okay. Next, let us add a aqueous solution of sodium hydroxide into this. If you add aqueous solution of sodium hydroxide into this, sodium hydroxide gives hydroxide. Hydroxide consumes this H plus. Hydroxide takes this H plus. Therefore, concentration of H plus getting reduced. So this is reduced means this which will favor here? Backward will favor. Backward is favoring means which concentration is getting dominating? So and so is dominating. This is dominating means it will give color to the resultant solution, no? This color only will appear in the resultant solution, no? Therefore, resultant solution will exhibit which color? This yellow color. Okay, sir. So now we said we are taking aqueous solution of sodium hydroxide. To this solution, we are adding methyl orange indicator. Now we are getting resultant solution. Resultant solution is appearing yellow. Okay, sir. So how indicator is behaving, that we have discussed superficially. We have discussed what is actual fact. How the indicator is giving color. Is it depending on pH or not? That we have to see. Okay, sir. First we will see about indicator equilibrium constant. We will see. Then we will come to that point. Now we will take indicator. Generally, acid indicator I will take like this. It is called acidic indicator. IN is called indicator. This H plus I have written indicates it is acidic indicator. Generally we have written. Why we have written like this? Because acid base indicators in the sense many examples are there for acid base indicators. We have discussed just one phenolphthalein we have discussed for acid indicator, and one methyl orange we have discussed for basic indicator. But actually acid base indicators in the sense plenty examples are there. Okay, so that I have written generally indicator in the sense acidic indicator in the sense I have written HIN. Suppose basic indicator in the sense INOH, like this we will write generally. Okay, so this acidic indicator on ionization gives what in the sense H plus and ion minus. Okay, so and so equilibrium is possible in the aqueous solution of acidic indicator. Basic indicator in the sense so and so equilibrium is possible, we can say. Sir, now we will write a equilibrium constant, we will write. So now we are going for equilibrium constant, that is KIN, indicator dissociation constant, we can say this is. This equilibrium constant we can call it as indicator dissociation constant because indicator is dissociating. Therefore I said like this. Okay. Now in this indicator dissociation constant, in the numerator what we have to write means this right side thing we will write in the numerator, that is H plus and IN minus we will write. Left side thing we will write in the denominator. Okay. So like this we have written. Now let us take log on both sides. Before that we want H plus, so take H plus, rest of the things take to another side. Therefore concentration of H plus is equal to indicator constant into HIN concentration by IN minus concentration. Okay, keep H plus one side, rest of the factors take to another side. Okay, so we got like this. Now take log on both sides and introduce negative sign on both sides. Then we will get what in the sense pH, we will get pH is equal to pK indicator constant plus log. Now it will be reversed, that is IN minus by HIN. Like this you will get. Okay, like this derivation we have seen already in Anderson equation, so that I have written directly like this. Okay, so pH of indicator in the sense that formula is pK indicator plus log IN minus is called ionized form, HIN is called a unionized form, we can say. Next, now this indicator we are adding into some solution, whether the solution is it may be acidic solution or basic solution, whatever the solution we can add indicator. In the acidic solution in the sense, do we feel that all the acidic solutions have same pH? Certainly no. Sir, now we will take particularly aqueous solution of HCl. Shall we say different concentrations of HCl will have same pH? No. Therefore, this indicator will give which color? This indicator will give particularly this color to the given solution, means that is possible at which pH, that we have to see. Similarly, this indicator is added into some solution. This indicator particularly should give this color, for which the solution should have what pH. How to know that? Okay, so what is the question? You understand it? We are adding this indicator into some solution. This form of indicator should exhibit color to the solution. This should not exhibit color. This is the condition. This form of indicator should give color to the solution. For that case, what is the condition required? In another question, this form of indicator should exhibit color to the solution. For that case, what is the condition required? Okay, so now what is the condition? You see that one first condition. First condition what means? This HIN concentration should be dominant in the solution. This HIN indicator is added into the solution. In the solution, this unionized form concentration should be dominant. Okay. Then solution will get color of this HIN form. This form, we have added the acid indicator to the solution.